Now that we've discussed sample statistics and distinguished them from population parameters, and gone over the three big characteristics of a distribution we attempt to describe, we're going to dive in a little deeper now into the common measures of central tendency and what those tell us about the shape of the distribution. By far, the most common measure of central tendency is the sample mean. The population mean is denoted by mu, and the sample mean is denoted by x bar. It is calculated by taking the sum of all the observations and dividing it by the number of observations. This can be done in Excel by typing in equals average and providing the cell range. While this is the most common measure of central tendency, it does have a downside in that it's influenced by extreme values. And when those extreme values are all on one side of the distribution, that is, the distribution is either skewed to the left or skewed to the right, that can make the mean misleading. We'll come back to that in just a moment. Now, when the data are binary, that is, the data consists of ones and zeros for all observations, we've referred to this as a proportion. The population proportion is denoted by pi, and the sample proportion is denoted by p. You'll note that the formula for p and how it's calculated in Excel are identical to x bar, the sample mean. We refer to this average as a proportion when the data are binary because binary data are treated a bit differently with respect to dispersion, which we'll be discussing in the next video. Now, when the data are skewed and the mean becomes misrepresentative of the central tendency, we typically report the median as a better measure of central tendency since it is robust to extreme values. It is simply the middle value of a sorted array of numbers and can be calculated in Excel by typing in equals median and providing the cell range. And lastly, I'll just briefly mention the mode, which is simply the most frequent value and can be calculated in Excel by typing in equals mode and providing the cell range. The mode's useful when you're dealing with attribute data such as sizes or colors or discrete data with a small range. The downside to the mode is that it might not be unique. You may have more than one mode, and it is not helpful for continuous data. So turning our attention to the mean, the population mean is denoted by mu, and the sample mean is denoted by x bar. It is the sum of the observations, so add up xi, where I goes from 1 to n, and divide it by the sample size n. So for example, here we have a sample of 10 houses with their sales prices, and if we add up all the sales prices and then divide by 10, we'll get a sample mean of $470,767. As I said before, it is affected by every item in the sample, including outliers. So for example, here we have a house that sold for over $1 million, which is pretty unique in this sample, and therefore that is going to inflate the mean price in this sample. Another property of the mean is that the sum of the observations' deviations from the mean is always equal to 0. That is, if we subtract the mean from each observation and then add up all those deviations, that sum will equal 0. So subtracting 470,767 from each of the houses' prices will result in the deviations that we see in the column to the right. And if we sum up the values in the column to the right, that sum will equal 0. The reason I mention this is because this is going to become problematic when we attempt to measure dispersion, and we're going to have to overcome this property of the mean. Next, we'll turn our attention to the sample median. The sample median is the middle of a sorted list of items. If your sample size n is odd, it is the middle observation of the sorted list. And if n, your sample size, is even, it is the average of the two middle observations. So returning to our sample of 10 houses and their sales prices, the first thing we will do is sort this sample from lowest to highest price. And since we have an even number of observations, we'll then take the average of the two middle values. So for example, in this case, we would add up 465,000 and 485,000 and divide that by 2 to get a median of 475,000. Now, looking at the mean and the median can actually tell you something about the shape of the distribution. When the distribution is skewed to the left, the mean will be less than the median. That's because the outliers are low values that are going to lower the mean but not affect the median. When the distribution is symmetric, the mean will be equal to the median, and this is because you have low and high outliers that offset each other. And when the distribution is skewed to the right, the mean will be greater than the median because the outliers will be large values that pull the mean up. So if the mean and the median are roughly equivalent, the mean is usually reported. And what do I mean by roughly equivalent? If the relative difference, that is the larger value divided by the smaller value, minus 1, is less than 5%, then you should consider them roughly equivalent. Otherwise, the median is the better measure of central tendency. So if the difference exceeds 5%, the median is reported. When the difference is less than 5%, the mean is reported. So let's look at a histogram of the distribution of house prices from a sample of 99 houses. We can see in this histogram that the distribution is clearly skewed to the right, where the outliers are on the right tail of the distribution. The mean price in this sample is $474,129, which is 17% larger than the median house price of $406,780. It's pretty clear looking at the graph that the median is a better measure of central tendency, as it is more representative of a typical house price in the sample. Now lastly, we'll talk about a sample proportion. The population proportion is denoted by pi, and the sample proportion is denoted by p. It is also the sum of the observations divided by the sample size. However, we refer to it as a proportion when the data are binary, that is, each observation xi equals 1 or 0 for all observations. The sample proportion is simply the fraction of ones in the sample. So p will be a value between 0 and 1. So again, returning to our sample of 10 houses, turning our attention to the far right column where it says garage, we see that all the values in that column are either 1 or 0, where 1 is indicating the presence of a garage and 0 is denoting its absence. If we take the average of this column, summing up those values and dividing it by the sample size, we see that 50% of the homes in our sample have a garage, or the sample proportion is 0.5. In our next video, we're going to discuss common measures of dispersion.